Hi, I'm Howard Nelson, CEO of RedShift Energy. We're a Texas-based corporation that was formed to develop and commercialize a novel plasma energy-based technology that transforms an unwanted hazardous waste into a clean and green source of hydrogen.
Worldwide demand for inexpensive hydrogen will be growing exponentially for the next 50 years. Refineries currently consume 25% of the hydrogen produced worldwide, primarily to remove sulfur in their raw product. The refining process turns the sulfur into hydrogen sulfide, then partially oxidizes the hydrogen sulfide in a Claus process to convert it into water and sulfur. This is a complete waste of perfectly good hydrogen. Thermodynamically, hydrogen sulfide is the cheapest source of carbon-free green hydrogen. Industry has long known that plasma dissociation of hydrogen sulfide is a promising and economical way of turning the Claus-based SRU cost center into a profit center. RedShift Energy is developing HSRT, Hydrogen and Sulfur Recovery Technology, a plasma process for conversion of hydrogen sulfide to sulfur and hydrogen. RedShift Energy's HSRT technology uses a patented method that is based on many years of R&D in the USSR, United States, and Canada. Plasma is the fourth state of matter, where particles are in a super-energetic state. 90% of the visible universe is made up of plasma. Matter in the plasma state can act very differently than the solid, liquid, and gaseous phases with which we're more familiar. Harnessing this behavior is key to how the HSRT system works. The key novel invention uses a controlled electric current plasmatron to create a high-temperature zone that separates the hydrogen from the sulfur in a one-way reaction that allows for the capture of the hydrogen. In HSRT, this zone is small, but the gas velocity is very high. This makes HSRT very compact in comparison with a Claus-based system. Specially arranged gaseous dynamics and special materials in the plasmatron make its operation stable, consistent, and reliable. Precisely tuned plasma and flow parameters make this process energy efficient and profitable. Our scientific team includes the co-founder of the Drexel Plasma Institute and lab director of a major oil and gas company, with a number of published and peer-reviewed articles on the subject. The HSRT has already been granted 2 patents and several more either in provisional status or in the process of being filed. We have finished testing our 3rd generation system and have begun feed for the 4th generation system in preparation for field deployment. Our testing has demonstrated electrical efficiency and has modeled a good flow design. Replacing the Claus unit with our HSRT will, when paired with renewable sources of electricity, create a zero-carbon process of recovering the hydrogen. Recycling hydrogen converts the SRU from a cost center into a profit center by reducing the quantity of hydrogen purchased or produced on site at the lowest thermodynamic cost of any viable source of hydrogen. Upstream, processing the H2S on site can extend the productive life of wells and potentially allows for using the cleaned associated gas to power local generators. Because this technology is electronic and thus modular, we can scale from the well all the way up to the largest refinery, and it retains its economic advantages throughout. It can be deployed wherever H2S is abundant. A broader application of the technology could be used to recover natural deposits of hydrogen sulfide, like the 4.6 billion tons of hydrogen sulfide dissolved in the waters of the Black Sea, which can now be profitably recovered and carbon-free.
On behalf of the RedShift Energy team, thank you for listening to our story.